All right. Now let's talk about velocity. When an object moves, its position changes over time, which means that velocity function is a change of position of the position function over time. Okay, we know this to be the derivative. Thus, we can say that the velocity function is equal to the derivative of the position function. V of t is equal to s prime of t. Now, let's take a look at what the sign of the velocity tells us about the motion of the object, okay? So let's just take a look at if the object is moving along a horizontal line, along the x-axis. If the velocity is greater than 0, it means that the object is moving to the right. If the velocity is less than 0, if it's negative, then the object is moving towards the left. And if the velocity is equal to 0, it means that the object is resting. The object is at rest. It is stopped. Okay? Now, if the object is moving along the vertical line, if the velocity is positive, it means it's moving up. Velocity is negative, it's moving down. And again, if the velocity is 0, that means that the object is at rest. Now, we know that speed is not synonymous with velocity. Speed does not indicate direction. And so the speed function is defined as the absolute value of the velocity. Okay, so you need to make sure that you remember how the object is going depending on the sign of the velocity. Now, what about acceleration? Now, the definition of acceleration is the change in velocity over time, okay? So again, just to reiterate, the acceleration is equal to the derivative of the velocity, which is also, acceleration is also equal to the second derivative of the position. So given a position function, we can now determine both the velocity and the acceleration function. Now, take note that if the acceleration is 0, it does not mean that the object is stopped. It means that the velocity is not changing, okay? So if you are driving a car, on your cars, you have two devices that changes the velocity. They are the accelerator, okay? It makes your car move faster, and then the brake pedal, which will, when you step on it, okay, your car would slow down, okay? And then until it comes to a complete stop. And then there is another device in your car that will keep the car's acceleration equal to 0. The velocity is constant. So if you're using the cruise control on your car, that means if you hit that, the cruise control, the velocity will not change. So if the velocity is not changing, the acceleration is equal to 0. Okay, let's look at an example here. A particle moves along the x-axis with the position function given by s of t is equal to t squared minus 4t plus 2. Okay, first let's find the velocity function and the acceleration function. So remember that the velocity function is the derivative of the position, okay? So we get the derivative of this, you get what? 2t minus 4. And then the acceleration function, on the other hand, is the derivative of the velocity. So we take this velocity, get the derivative, so your a of t is equal to 2. Okay, now let's complete this chart for the first 5 seconds and show where the particle is on the number line. Okay, let me just bring this up. Okay. So at t is equal to 0, your s is equal to 2. At t is equal to 0, the velocity is, we plug in 0 to t, it's negative 4. Okay, the speed, that's the absolute value, is positive 4. and the acceleration is 2. Okay. Now let's fill this table first, and then we'll write down the description. Okay, so at t equals 1, you can use your calculator. At t equals 1, the position is -1, the velocity is negative, no, 1, if t is equal to 1. Okay, so the velocity is equal to -2. The absolute value of the velocity is +2. The acceleration is also 2. So notice that the acceleration is not changing no matter what the t function, the value of t is. So when t is equal to 2, your position function is -2, velocity is 0, absolute value is 0, acceleration is 2. When t is equal to 3, position is -1, velocity is 2, absolute value of velocity is 2, acceleration is 2. If the time is 4, position is 2, velocity is 4, absolute value of velocity is 4, acceleration is still 2, and when t is equal to 5, position is 7, velocity is 6, absolute value of velocity is 6, and the acceleration is 2. Okay, now let's put this in our number line, the position function. So at time t equals 0, this is the initial, the position is at 2. So this is at t equals 0. At t equals 1, it is at -1. At t equals 2, the object is at -2. At t equals 3, it goes back to -1. At t equals 4, it goes back to +2. And at t equals 5, it moves up to 7. Oh, that should be 5. All right. Now, let's look at the description. All right. So for the description, we want to identify whether the object is moving to the left or to the right. Okay. And whether it is being, okay, let's take a look at this. So say, for example, you are walking towards the right. Okay, you're walking towards the right. Now, there is a force of wind that's going in the same direction, a strong wind going in the same direction. So what happens here? You would be walking faster, right? Because that force of the wind would push you towards the same direction. However, if the wind, so you're walking to the right, so you're walking to the right, and the wind, strong wind, is blowing in the opposite direction, then what happens here is that the wind would be pushing you backwards. So you would tend to walk slow. You would tend to be walking slower, right? So if the direction of the velocity and the direction of the acceleration, so this is your acceleration, that's your acceleration, this is your velocity. If the acceleration and the velocity is in the same direction, both of them are positive or both of them are negative, that means that the object is speeding up. Okay? But if the velocity and the acceleration are in opposite direction, that means that the object is slowing down. So let me write it down here. If velocity and acceleration have the same sign, it means that the object is speeding up. However, if the velocity and acceleration have opposite signs, that means that the object is slowing down. Okay, so let's apply that here. We're looking at the velocity and the acceleration. So velocity and acceleration. So at time t equals 0, okay, your velocity is negative. So that means that the particle is moving left, okay? So particle moves left. Okay, now is it speeding up or slowing down? So let's look at the sign. Negative, velocity is negative, acceleration is positive, they are opposite side. So we say that the particle is slowing down. Okay, let's take a look at the first one. Second one, at t equals 1, velocity is negative. So that means that the particle is moving to the left. So same thing. Okay, negative and positive, the velocity and acceleration have opposite signs. So that means that the particle is also slowing down. Now at time t equals 2, the velocity is 0, which means that the particle is stopped. It's not moving. And of course, if it's not moving, it's neither slowing up, slowing down, or speeding up. It's just stopped. At t equals 3, the velocity is positive, which means that the particle is moving to the right. Okay. And then the velocity and the acceleration have the same sign. So same sign. That means that the particle is speeding up. At t equals 4, the particle is moving to the right since velocity is positive. Velocity and acceleration are both positive, so the particle is speeding up. The same is true when t is equal to 5, particle is moving to the right, and the particle is speeding